All right, so this is it, guys. This is like the everything I taught you. Try to like get you up to right here to synthesis. All right. So for this chapter, we haven't had a lot of reaction yet. You probably think that's not a lot. Oh my God, we have a lot more waiting for you. We have like a few more chapters to go. All right. Anyway, so that's not a lot yet. We're gonna start with the easiest step. So we have one step synthesis, and then we're gonna go to multi-step synthesis. And once we go to other chapter, we're gonna incorporate all those reactions and do more and more synthesis. So basically, we're gonna increase your library of reaction, of the recipes. Okay. All right. Start with the basic here. So one step synthesis. So what do we do? The reaction that you're gonna use, we have substitution. All right, so nucleophilic attack on right there. All right, we're gonna do elimination from the alkyl halide to a double bond to an alkene, and we also have addition. That's just one step there. All right, all right. Let's take a look right here. So one step synthesis. What's going on in here? So analyze the starting material and the product. All right. Can you see that the number of carbons are different? Carbon on the left side, so 6 and 7. On the right side, just 6. Right, the right side just 6 carbon. So carbon is missing. What reaction removes or cut a carbon chain? Remove the carbon. There's only one. Ozonolysis, right? There's only one. Ozonolysis is to cut the bond, right? So that's ozonolysis. So you got two options. You either use ozone or use permanganate in elevated temperature, right? The only difference is ozone will keep aldehyde, stay as aldehyde. But the permanganate will further oxidize aldehyde to carboxylic acid, right? But it doesn't matter. You're gonna get ketone anyway. This is ketone. That doesn't matter. So use either one. So I'm gonna go with ozone, and then reduce with zinc and water, or you can use DMS as well around here. All right. So again, analyze the product and the reactant. What's going on, and think back to the all the recipe or the reaction I show you, stereochemistry, talk about what the product look like, and then apply to what you want to do in the synthesis. All right. So if you add ozone, it will cut this bond right here. One part you're gonna have which is cyclohexanone. Right. The other part right here on the right, you're gonna get with formaldehyde to hydrogen on it. All right. If you use permanganate, you're gonna get cyclohexanone and carbon dioxide. This is terminal alkene. All right, right here what we got looks like, so we adding bromine on here. This is more substitute carbon. See that? This more substitute carbon. Adding bromine and hydrogen. Hydrogen goes on here. You should realize that that's a Markovnikov orientation, and there's only one reaction that you can do this. HBr. That's it. All right. All right. Next one. What we got here down here. Analyze it real quick. So we adding on OH for sure, and also the hydrogen behind it right here too. All right. So we add an OH and a hydrogen, and the orientation is this is an anti-Markovnikov. Yeah. So Markovnikov should it would have gone to the carbon in the middle right here, more substitute carbon, but OH go here. This is anti-Markovnikov, right? And also syn addition. So down, dash and dash, and then wedge and wedge. So syn on the same side, right? There's only one reaction you can do anti-Markovnikov for adding water, hydration. We use borane, right? Hydroboration-oxidation. Okay. All right. All right. One more time. So let's see what's going on in here. So we add bromine and hydrogen, anti-Markovnikov orientation. So we're gonna use HBr and then use what's it called, peroxide and light to initiate the reaction. Okay, let's go anti-Markovnikov. Lastly, bromine right here, substitution alkyl halide, and we get a double bond, totally elimination. All right. Now, how did you eliminate them though? Well, what base you're gonna use? So elimination require base. You can do E2 here. Don't do E1. The E1 is compete with SN1. All right. So we're gonna do E2 here. So if you do E2, you got two options, right? Either go to Ch8 and Hoffman. This is go less substitute alkene. Okay. So this go Hoffman. Totally bigger base, bulky base. Okay. Small base go Ch8. You still remember that? Bulky base go Hoffman. right? So if you look at the structure here, so small base is going to go down, put double bond right here. Okay. And the bulky base is going to put double bond on the left side right there. All right. So we can use LDA, third butoxide, triethylamine. What's the other one? Diisopropyl ethylamine. You can work. Yeah, that's a lot of them you can use. All right. All right. Class activity number 5. Question 1. Question 2. This is all ozonolysis. All right. The key is right here.